Hello everyone, welcome to my YouTube channel, Engineering E-Learning Hub. So in this video, we are doing static analysis of truss using SolidWorks. So truss was given here. So it's having two elements with three nodes, node number one, node number two, and node number three. And the cross section of the member was given as a square cross section with 45 breadth and 45 height. And the material used here is ASTM A36 steel. So let's start the static analysis of truss. So click on front plane and click on normal tool and then click sketch and select the line here, and then from the origin draw a line escape. Now go for smart dimensions. This has 45 and edit this 45. This point to this point, this is 5,000 as given. We have this point, this point to this point. I will smart dimensions from this point to this point, which is 2,500. Next, I need to take that angle. So for that, dimension, this line and that line, the angle should be 45 degrees. So check whether it's okay or not. So this is what our outline. Next, top zone. Here randomly drawn line. Dimensions of that line. So it should be 45 mm. And this is also 45 mm. This should be so select this point and the midpoint of this. So here we can see that which is 2.92 mm. So we should reduce it to 0. Should be. See. So now draw a line from one corner to the another. So you have already selected it, and then go for zoom to fit, and then we're having this point here. That's it. Next, box zoom. We'll select this point, and then select this zoom to fit, then another end point. Not visible. Take this box zoom, zoom it, close this box zoom, and then just click here and click OK, and go to the features, and then extrude boss. So extrude it to 45 mm. So now our truss is ready for analysis. So you can see the details also. This is what the truss. Then go for evaluate, and then simulation express analysis. Then now, say both are visible, but take this box zoom, close that box zoom, and then click on the surface and zoom fit, and then take this box surface, box zoom, and then click on this bottom surface and click OK, and click on next. Now the portion is to apply load. So load, you're going to apply it on the top. So add a force, click on the surface, and then here it was given 1000 kilonewtons, so that 100 kilonewtons, so 103 zeros. Then click OK. So direction is OK here. So next to click next, then go for choose material. The material you're going to select here is ASTM A36 steel. Click on apply, close it. So here it was shown. Then click next, click run simulation, wait for results. So to see the deformation, click on this isometric view. So you can see the animation of a simulation. And click S to continue. Then click on show 1 meso stresses. So these are the 1 meso stresses. You can see that 2.5 e power 8 is its yield strength, whereas the maximum stress is 6.13 e power 7. So our structure is safe. And then displacement, we can see displacement is maximum displacement is 1.008 e to the power of 0. That means 1 mm is displacement. So click on done viewing results, and as same to that of our last video, which is on stepped bar. So we can generate the report here. Okay. So here I'm not showing the generated report as shown in the stepped bar. So you people can generate the report and then collect it.
Like, comment, and subscribe.